Alright, so let me go ahead and zoom this in so we can kind of see what we're doing here. Okay, so the first set of additions that they're showing us in the notes is basically they have the common denominator, so there's not much to be done. So let's go ahead and do 2 and 3. I'm going to go ahead and do 2 with you guys, and you guys will do 3. So rational expression. The good thing is they have a common denominator, so I don't have to do anything. My common denominator is x minus 4. And you just add the 2, so 3x plus 6. Before you do anything else, go ahead and write your restriction. Your restriction is x cannot be equal to 4. Alright, so pretty straightforward. If at this stage, if you can take out the greatest common factor or factor in any way, because sometimes you can simplify. There may be a common factor to your numerator and denominator. So let's see if there is. I don't think there is, but let's go ahead and factor I can factor my numerator because I can pull 3 out. It's x plus 2. It's x plus 2. It's not x minus 4, so I cannot cancel. So this is my final answer. Daniel, did you find the notes? All right, can we all do 3? So 3 at first glance may look like it's not common denominator, but it is, because you should be able to factor the second expression. So before you do anything, go ahead and factor the second expression, and you will notice that it is the same. Right, everybody good? They're both x plus 1. So go ahead and write your x plus 1 as the common denominator, and you're subtracting the numerator in this case. And go ahead and write the restriction also. So this negative 6 over x plus 1 is the final answer, and x cannot be equal to 0 because x is by itself, and then x plus 1 cannot be equal to 0, therefore I get negative 1. Everybody okay? Alright. So this one is straightforward because it has a common denominator. The ones we're going to see in the next page, they do not have the common denominator. So like I said, the first thing we're going to learn is to find the common denominator. To add, subtract rational expressions, you need a common denominator. We already know that, just writing it down. Preferably the least common denominator. And I feel the word least confuses students, so I will talk about this. And I'll tell you why the word least is used. And I'm going to go ahead and explain how you find common denominators. So if I look at this, right, we had done this with numbers. 1 over 7, and I had added with 1 over 49. For this, what will the common denominator be? So that's why I feel the least kind of trips some students. So instead of 49, they say 7, but it's actually 49. Why is it 49? Because I can multiply 7 with some number to get 49. You need a number that the rest of the rational expressions you can multiply with something to get this 49. So if I have 49 as my common denominator, I can multiply the top and bottom by 7 to get 7 times 1 is 7, 7 over 49, 1 over 49. Therefore, it's 8 over 49. Right? We're good? Okay. Let's look at something else. Let's look at 1 over x plus 1 over x squared. Okay, I will take 1 over x. I will take my LCM, my least common multiple is going to be x squared. Why? Because I can multiply I can multiply the top and bottom with x, because x times x becomes x squared, so my x squared is a common denominator. But how did I come to that conclusion? Because this one is a little straightforward to see. This one is a little straightforward to see. But how do you come to that conclusion? What you do is, and that's what this is going to say here. Write each denominator. So it's going to give you the steps, but I'm going to talk about this and then we'll write it down. What you're going to do is, for every rational expression, you're going to write all the factors. So you're going to take this. The factors of x is only x. The factors of x squared is. Alright, so that's the first step. First step is you write down all the factors. This is your step number 1. Step number 2, take all the factors except the repeating ones. So you basically take everything. So you go look at the first one. Take this x. Take this x. Go to the next one. You have 2 x's. Out of the 2 x's, 1 x is already, you've already picked 1 x. So between the two, of the 2, you need to pick only 1 because 1 is already repeated, and that's how I got my LCM as x squared. So that's going to be your step every time. You're going to factor out all the rational expressions. You're going to write down the factors of all the denominators and pick all the factors except the ones that are repeating. May look confusing. As you do some problems, it will get clear, I promise. Okay. So the steps are to find the LCM, write each denominator as a product of prime factors. All this is saying is write all factors of the denominator. I'm sorry, here. Write all the factors of the denominator. Step number 1. Multiple denominator. Step number 2. Form a product of all different prime factors. Okay, but to put this more simply in a language that it's a little easier to understand, take all the factors except the repeating ones. Take all the factors. Once you write all the factors, you take all the factors except the repeating ones. And that's what I did when I did my x and x squared. Okay, I'll wait for a minute for you guys to write this down. If my handwriting is not clear, please ask me. I do scribble. Take all the factors except the repeating one. Okay. I'm going to start from, I'm going to skip 4 because 4 actually does not have any common factors. I'm going to go straight to 5 because it's a better example to start with. So here we are not adding, here we are not adding rational expressions as yet. I'm just teaching you how to find the common denominator between different denominators. So if x was a denominator to some expression 1 over x, if x square something, so these are my 3 denominators of 3 rational expressions. How do I find a common denominator between x plus 5, x squared and x? So start writing the factors for each one of them. So the first one is x plus 5. X plus 5 is a factor by itself. Remember, addition does not create factors, it's a multiplication. So x plus 5 is just x plus 5. There's no, you cannot break it up into any other factor. It's a binomial factor. X squared can be written as x multiplied by x. Everybody good? And x can be written as just x. There's nothing to be written. So my LCM is going to be, okay, you want to start with the first, factor. So just write down the x plus 5. The first one you just write because there's nothing to compare. Because remember, step number 2, take all the factors except the repeating one. Okay, thank you. Except the repeating one. So I'm going to take x plus 5. Then I'm going to come to the next one. I'm going to take both the x's because right now I'm not seeing even one x. Okay? So you're going to take x and x. Because x plus 5 is not, remember you can't break it up as x and 5. It's a factor by itself. It's a binomial factor. And then, oh, did I write 1 here? Where did I write 1 here? The factors of x is just x. And then I come to my third rational expression and look at the factor. There's an x here, but there's already 2 x's here. So there's at least one x. So that's it. This is my factor. No, this is my LCM. x square, if I need to write it properly, it's x squared times x plus 5. But I will also accept it in this form because it's okay to leave it in the factored form, and you'll see why. It kind of makes it easier to simplify later. Yes? I'm sorry, I can't hear you. Well, so the repeating thing you take into account only when you're trying to solve something. So the value of x, so if you're trying to solve x squared equals to 0, x equals to 0, it's a repeating factor. But it's still, the factors are still x and x. So repeating, the whole thing about repeating comes into play only when you're trying to solve. Yeah? Okay, good question. Because that's my LCM. Everybody clear? Okay, let's go ahead and do 6 all by ourselves. You start, I will follow, so you can check your answer. So it is x, x2 and x minus 3. The rest of it I leave. So if you want to write this in a proper way, it's 2x squared x minus 3. Why? When I come to my second rational expression, 2 and x, I only take 2. I already have an x. I come to my third expression, it's x, x minus 3 is my factors. I already have an x, you take only x minus 3. So that's your LCM. Everybody good? Okay. I just think we should practice as much as we can. So let's do 7. We'll do 7, 8 and 9. If you're comfortable with those three, we can move on. So let's do 7. Can we all look at 7 if you're done? That is if you're done. I leave out the x from my third. So 1 is nothing. 1 is, you can't do anything. It's something over 1. So remember, 1 is my denominator. So something over 1, I don't have to worry about it. So I write 3x, and then this x I leave out. I take only x plus 1. Okay, if you're good, please go on to 8. Can everybody recognize x squared minus 4 factors, difference of square, right? Can we all check 8, and then please go on to 9. should have the answer for 9 if you're done. Yeah, so the only thing you leave out is the x plus 2 in the second expression because x plus 2 is already existing. Yeah, everybody okay? Okay, I'll wait for 30 seconds, see if anybody has any questions. And please let me know if you want to do one more, otherwise I'll go to the next page. You let me know. So do you have to multiply these out? Not really. It's good to leave it in the factored form, and you'll see why. When we actually add the rational expressions, it helps to leave it in the factored form. Yeah, anybody, any questions? Okay.